Okay, so now we're going to learn about a couple more types of shifts that we do. Again, we're kind of going to college algebra. We have y equals f of x, and we've seen that if I multiply the f of x, we get a vertical stretch or compression. If we multiply the input by something, we get a horizontal vertical stretch of compression. And what we're going to do first in this new section 4.2 is talk about shifting this up or down, or shifting it left or right. And then once we do that, we'll put it all together, and we'll go from there. So let's again recall from college algebra that the way that we get a vertical shift up or down is by taking our function and adding some value to it. So we're basically taking all my old y values and adding c to that expression. So again, our classic situation is with our good old x squared, right? So going back to college algebra, y equals x squared. So if I wanted to graph x squared plus 5, right, I'm basically going to take this graph and it's going to be shifted up, right? 1, 2, 3, 4, 5. So it's basically going to go to here, all right? And comparing it to the old graph, right? If that graph, if that point is 1, 1, then it's basically shifting up to 1, 6. So notice that we added 5 to all the y values. That traditional point, negative 1, 1, now becomes negative 1, 6. So again, we added 5 to all the y values. Of course, if I wanted to shift down, right, then I would basically take all those y values and shift them down. So this would be 1 comma negative 2. So I subtracted 3 from everything. The corresponding point here would be negative 1, negative 2. So I subtracted 3 from everything, from all the y values anyways, to get the shifting up or down. So that's essentially what we're going to be doing with our sines and cosine graphs. And again, what it comes down to get yourself a good, clear label of extrema and whatnot, what we basically do is take a look at our key data points. So here we know we're taking our cosine graph and we're adding 2. So we're going up by 2. So let's go take our data, right? Our core data for a cosine graph is basically, you can get that straightened out there, 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and then 2 pi, 1. And so we're now going to get this new graph, right? This is the old graph, is we're going to basically add 2 to all the y values. So my new coordinate system, right, basically becomes 0, pi over 2, pi, and 3 pi over 2 and 2 pi are all staying the same. We're not impacting x values, but all my y values are going to be increased by 2. And so when I add 2 to them all, right, 1 plus 2 is 3, 0 plus 2 is 2, negative 1 plus 2 is 1, 0 plus 2 is 2, and 1 plus 2 is 3. And now what we have is at least one nice cycle, right, for cosine of x plus 2. And so scale-wise, along the x-axis, we have our nice traditional pi over 2, pi, 3 pi over 2, and 2 pi. And along the x-axis, we're 1, 2, 3, so perhaps you know, we go 1, 2, and 3, right? And then negative 1, negative 2, negative 3, respectively. But graphing, we have 0, 3 as the first point, right? We have pi over 2, 2 as a second point. We have pi and 1 as the next point. 3 pi over 2 and 2 is that point, and 2 pi, 3. So there, oops, went a little high there. So there is the first cycle of this new graph. Of course, it would go on forever in this direction and go on forever in that direction. Okay, and comparing it to the old sine, right, with cosine, cosine does this, right, in the first rotation from 0 to 2 pi. So essentially the graph has been shifted up, right, plus 2 units in all things. So here's your cosine graph with no transformations. And in red, here's your cosine of x plus 2. All right, and then what we are talking about is equilibrium. Notice that for the original graph, the amplitude is 1. We're 1 above and 1 below what is the x-axis, our equilibrium. So it's kind of the average value as we go through. If we were to add up all the y values, on average, we would be 0 because everything's kind of canceling each other out. But because we added 2, notice the equilibrium, right, is now the line x equals 2. So the equilibrium shifted up. We're 1 above 2, we're 1 below 2. So on average, this function is bouncing around 2. So we call this an equilibrium shift, even though back in college algebra we called it a vertical shift. For circular functions, it's called an equilibrium shift. We're shifting that equilibrium where my wave bounces back and forth around, right? We're shifting it up 2. And so same thing here, we got a sine graph. It is also going up by 2. Again, manipulating data points for sine, excuse me, right? The core data for sine is 0, 0, and we have pi over 2, 1, pi is 0, 3 pi over 2 is negative 1, and then we get 2 pi is 0. And so we're basically, to get our new graph, we're adding 2 to all the y values. So my new coordinate pairs, 0, pi over 2, pi, 3 pi over 2, and 2 pi, we get, we're adding 2, so we get 2, 1 plus 2 is 3, 0 plus 2 is 2, negative 1 plus 2 is 1, and 0 plus 2 is 2. And so putting this all out there, we have, as far as a first initial thing, we're going to break this up in its normal quadrants, right? So these aren't changing, but we're from 1, 2, and 3. And again, our equilibrium is now shifted up to 2, right? And so we're going to see a wave that bounces back and forth. So we're 0, 2 to start with. So we start on equilibrium. Pi over 2 is 3. Pi is back on the equilibrium 2. 3 pi over 2 is 1. And then 2 pi over 2 is back on the equilibrium. So here is the graph in red of the sine of x plus 2. Of course, if we compared it to the original graph, right, the original graph would be down here, right? So in blue, there's the graph of sine x, and you can see it's basically been shifted up by 2. We used to bounce around the x-axis. We're now bouncing around x equals 2. And we can still see that we have an amplitude of 1, right? We're 1 above it, we're 1 below it. Our wave's basically bouncing around the equilibrium of 2. Okay? And so that's pretty much it. I mean, we probably don't even really need the data points if you're kind of following what goes along. Because here what we're doing is we're basically going down by 3. All right? And so we're basically going to take, how about I just manipulate the graph in this case? So if we manipulate our normal cosine graph, right, we have, again, pi over 2, pi, 3 pi over 2, and 2 pi, right? And we know a normal cosine graph, oops, let me, kind of getting prepared here, negative 1, negative 2, and negative 3, right? A normal cosine graph starts at 0, 1, 0, negative 1, 0, and 1. So what I have in blue is what cosine of x does. But here, since we're shifting it down, right, 1, 2, 3, right? 1, 1, 2, 3, right? And then 1, 2, oops, I think I'm a little off the board there. Sorry about that. 1, 2, 3, right? And then 1, 2, 3. So our graph is going to shift down by 3, and our equilibrium is now, right, let me put that in blue. Our equilibrium is y equals negative 3. So everything has been shifted down by 3 units. So I just went ahead and manipulated, I manipulated the points, but you see me basically subtracting 3 from all the y values. And same thing here, again, we're going down. I'll try to make sure I stay up here a little bit better. So our normal quadrants are this guy, right, because we're not impacting the x. We have negative 1, negative 2, negative 3, and negative 4, right? And so in blue, a normal sine graph starts at 0, goes to 1, comes back to 0, goes to -1, comes back to 0. So there's our normal sine graph, right, over one period. And what this guy's doing is we're subtracting 3 from all the y values. So we go 1, 2, 3, 1, 2, 3, 1, 2, 3, right? 1, 2, 1, 2, 3, and then 1, 2, 3. And so in red, there's basically sine of x minus 3. All right, it's equilibrium now. We're bouncing around. X equals -3. So we're one above it, we're one below it. So on average, we're right around that. But you basically see the whole graph being shifted down. So the period's not being impacted, the amplitude's not being impacted. It's still 1. What's being impacted is what we're bouncing around. So we were bouncing around the x-axis, but if we shift up or we shift down, what we bounce around with, what we call the equilibrium, has now changed. Alrighty, so there you have that. We'll handle how we do horizontal shifts and in the next video. So I'll see you guys then.